Hi everyone, welcome back. In this video, we're going to take a look at inverse trigonometric functions, specifically inverse sine, inverse cosine, and then inverse tangent also. We're going to look at how these inverse functions involve reflecting across the y equals x axis, and then we're going to look at the restrictions that we put in order to keep them as functions. Okay, so what we're going to do now, I'm actually going to start off with just looking at Desmos really quickly. So here we have a graph of sine of x. And let me change the axes really quickly to make it a little bit more clear. Okay, so here you can see sine of x. Every 2 pi, we have a repeating sine function. And what we want to do is take the inverse of this. So taking the inverse would mean looking at the y equals x line on a graph and then flipping it across the y equals x line. If we were to do that, we would end up with a graph that looks like this. So inverse of sine. Unfortunately, this isn't a function. So what we need to do is restrict our sine graph so that when we flip it, we end up with only a function, and we have a function that passes the vertical line test. In other words, it doesn't go through a vertical line more than once. So what we do is we're taking a look at our sine graph. We're restricting it here at pi over 2 and negative pi over 2. We're just looking at these two parts. And then we'll just take this section and then flip it over. And when we do that, we end up with this graph. So reflected across the y equals x line. As you can see, it is a function, so it passes the vertical line test. And then we get rid of the other ones. That's what we're left with. And because we switched the domain and range, I'm putting the range in terms of pi and then the domain in terms of just 1. So as you can see, the domain is in between -1 and 1 inclusive, and then our range is in between negative pi over 2 and pi over 2. So when we're using the inverse sine function, we're just going to be looking at this section of the sine graph. So we're just looking at one piece of the sine graph, and that's to ensure that we only end up with one output for every single input. We do a very similar thing for cosine of x. So here we have a graph of cosine of x starting at 1. Go ahead and flip the units again. Starting at 1, eats every 2 pi. Again, we're going to be looking at flipping this across the y equals x line. If we were to just flip it across the y equals x line, we would get a graph that looks like this, which again is not a function. So first, what we want to do is restrict our domain. So we're going to take cosine of x and we're going to restrict it in between 0 and pi. 0 and pi. So we're just taking a look at this section of cosine of x. We're going to take this, we're going to flip it or reflect it across the y equals x line, and what we end up with is this graph right here. Flipped across the y equals x line, we take it, flip it, and then as you can see, we end up with a function that passes the vertical line test, and again, we're just looking at one piece of the cosine graph. Let's go ahead and change the units again, just to make it a little bit more clear what the domain and range restrictions are. So as you can see, our domain is in between -1 and 1. And then our range, we're restricting between 0 and pi. So for sine and cosine, we're taking a piece of the graph, reflecting that, and then we're just looking at that piece. And this is what it looks like graphically when we apply those restrictions. Okay, let's finally take a look at tangent. So here I have a graph of tangent. You can see we have these repeating curves. It's a periodic function, repeats every pi units, 0 to pi to 2 pi. So the period is a little bit shorter than sine and cosine. If we were to take this and just flip it all across the y equals x line, we would end up with a graph that looks like this, which clearly is not a function. So again, we're going to restrict the domain of tangent of x, then we'll flip it, and then we'll end up with a function. So we're just going to take a look at one of these sections of the graph. So in between two asymptotes, and our asymptotes are at pi over 2 and negative pi over 2. So we're just taking a look at this middle part. Again, we're going to take a look at the y equals x line, and then we're going to reflect across the y equals x line. So our graph ends up looking like this. So this is our graph of inverse tangent of x. Like before, I'm going to change the units so it's a little bit more clear. As you can see, our tangent graph has a domain from negative infinity to infinity, so it keeps going on forever, hence the asymptotes. And the range is between pi over 2 and negative pi over 2, because those are the vertical asymptotes that we have for regular tangent. So when we flip it, they're going to be horizontal asymptotes. All right, so everything we just looked at is written down on this page right here that we can see, this slide right here. So when we talk about inverse sine, inverse cosine, inverse tangent, we use the -1 superscript. It's kind of like an exponent, but again, it doesn't mean to the -1 power. It's just how we indicate that we're talking about inverse. So again, we're looking at when we talk about y equals inverse sine of x, we're trying to find the y value, where if we plug it into sine, we end up with x. So let's write this down. We're trying to find the y value, where if we plug it into sine, then we end up with x. And the restrictions that we saw in the graph are all listed down here. So our domain's between -1 and 1, and our range, so that we end up with a function, is between negative pi over 2 and pi over 2. Same thing for cosine. When we are trying to find inverse cosine of x, we're trying to find this y value. What that means is we're trying to find the input that gives us an output of x when we plug it into cosine. So it's just kind of reframing the question, figuring out a puzzle. What input do we need in order to get a certain output? For cosine, similarly, the domain is between -1 and 1, and then our range, as we saw, is between 0 and pi. Finally, for tangent, same idea. Y equals inverse tangent of x. Find the input that we need to put into tangent to end up with an output of x. And then we saw our domain on our graph is between negative infinity and infinity, because we have those asymptotes. And then the asymptotes are going to be between negative pi over 2 and pi over 2. So these are all of those restrictions we saw in the graph, just written out mathematically using inequalities. All right, one more note is when we talk about inverse functions, f of x and f inverse of x, just a reminder that when we plug in an inverse function into its original function, for example, f of f inverse of x, they undo each other and we end up with x. And the same is true if we plug the original function into the inverse. F inverse of f of x equals x. One quick note is, so this is true for sine and inverse sine. Sine of inverse sine of x gives us x. Inverse sine of x equals x. So they, in a way, kind of cancel each other out or undo the operations that we're doing to x. The only note is that the domain is still restricted in this case, because we have domain restrictions for inverse sine. So here the output has a restriction. Our output for inverse sine of x has a restriction. And what that means is that what we end up with, x, is going to be in between pi over 2 and negative pi over 2. Up here, the input has a restriction. Inverse sine, what we're plugging in, has a restriction. So we are looking at x values between 1 and -1. So there is just a restriction on the domain, even if they cancel each other out, just because we had to restrict domains in order to end up with functions for the trig function. Okay, and one last thing I wanted to take a look at was using a calculator to calculate inverse trig functions. So here I just have the Desmos scientific calculator up, desmos.com/scientific. And you'll start off on this page. If you ever want to calculate an inverse trig function, so here we have the trig functions on this main section, you can go to the function section. Different calculators have different sections, but most scientific calculators should have an area where you see the inverse sine and cosine and tangent. So here we see sine, cosine, tangent, and then we have inverse sine, inverse cosine, and inverse tangent. So for inverse sine, for example, of 0, that's just going to give us 0, because we input 0 into sine to get an output of 0. For inverse cosine of 0, we know that we need a 90-degree angle to get 0. So an input of 90 degrees gives us inverse cosine of 0. And here, calculators usually have two modes, degrees mode and then also a radians mode. So we can also switch this to radians, in which case it gives us the answer in radians, 1.570 ... radians. And if you ever want to take an answer like this in radians and put it in terms of pi, one good way to do that is to take whatever the number is and then divide it by pi. And that tells you how many pi's are in it. So pi over 2, or 1/2 pi's, which makes sense because pi over 2 is 90 degrees, and 90 degrees gives us an output of 0. One more we could do, so inverse cosine, for example, of square root of 3 over 2. Oops. Divided by 2. So here in degrees, it's 30 degrees. For radians, we end up with this number. And again, we can just take it, divide it by pi, and we see that we end up with 1.666667. In other words, we have pi over 6 in this case. So that's how we can use a calculator to calculate inverse sine, inverse cosine values. We do want to keep in mind those domain restrictions, though, because our domain and range restrictions, because those will affect the answers.